yeah, I never had the intent of going over all of these.
Oh, okay.
I think I went over the really easy ones. I made sure I went over the serious ones first.
Can you tell us the answers really fast to the quiz?
Sure.
All right.
I don't want to know, dude.
You don't want to know the answer?
No.
Seriously, guys, that really was a fun quiz.
Yeah.
Nick was better than most of them.
You know, I typically go to Walmart every once in a while. I buy some door stoppers. The stores, they keep disappearing. But I think this week I'm going to ask Matt tomorrow if I can use these computers instead. Get some good use out of them.
It's better to go to Walmart.
Go to Walmart.
Those lines are ridiculous. Every time.
You get there at like 12 o'clock at night, and there's one like 80-year-old woman working at the register, and everybody's lined up to the back of the store.
Yeah, very fun.
Disgusting. I thought it said 67, so I was like,
Coffee.
it's such a serious.
Aw, you guys just talking into posting it. Let's check it out. So that's my first line.
Woohoo.
So far so good?
Yep.
Next line?
Yeah.
And then final value.
1.19?
Oh, you guys make me
1.19.
happy,
All right.
Maybe? No?
Yes.
Whew. I'll have like drop and then get twice or something, so it's not very. It's why you always answer math questions or math quizzes and tests in pen, so you don't make any mistakes.
Oh yeah, that's so much easier.
I use Sharpie.
So you guys from last time, yes or no response. Do we all know what it means to have a function that's increasing over some interval?
Yes.
And then decreasing?
Yep.
It's just that, in this picture, x-axis, y-axis. Here's y equals f of x. Here's a value of x, x of 1. Here's a value of x, x of 2. Over what interval is this function increasing? So negative infinity up to
Infinity.
x of 1.
And X of 2.
Parentheses.
Close
Parentheses.
bracket.
No, parentheses.
And over. Open bracket. X of 2 to infinity.
Wait. Why is it closed?
Close.
Why is it closed?
Because it's
Why?
Yeah.
Why?
decreasing.
Because it's not increasing, and yeah,
Because when you go from...
It stops increasing at X sub 1 and it starts
it's
decreasing
flat.
again at
It's
X sub 2.
the slope is at 0
You
at
guys, I
that
think
point.
we're wrong. Because I think at x of 2, the tangent line is horizontal. Doesn't
Yeah.
mean I'm not increasing.
Yeah, you're not doing anything.
If you zoom in on
I'm
it,
transitioning, though.
it is increasing.
I think it is. I think I have to include that left hand point x2 for this reason. The definition of increasing over some interval is this. You plant your feet at one value of x with your left foot, And with your right foot, you plant your feet at another value of x to the right of it, but not on top of it. And I think if I include the left endpoint, then any other point in the curve somewhere to the right of it, however close, is going to see an increase in the y values. I do think I need to include the endpoints. I also think that f is decreasing over the interval from to,
X sub 2.
but I include the endpoints. I bracket them very
it's both
nice.
increasing and decreasing at x sub 1 and x sub 2.
No, as a matter of fact, I can't even use that phrase in mathematics. I can't talk about increasing and decreasing at a value of x. All I can do is talk about increasing and decreasing over an interval. And that's why there's no contradiction here with the overlapping of these intervals. I got to.
Okay, let me rephrase.
Yes.
X sub 1 is part of the interval that's increasing and part of the interval that's decreasing.
I agree with that.
You have to go back.
So is the horizontal line both increasing and decreasing?
No, because when it comes to horizontal tangent line, just because a tangent line is horizontal at a given value of x doesn't tell you anything about increasing in this and decreasing this over the interval. It's only at a single value of x. So going back to my man-made definition of increasing and decreasing, check this out. Definition. I will say that f is increasing over some interval I, provided that f evaluated at x sub 1, did I say increasing or decreasing?
Increasing.
Increasing. F evaluated at x sub 1 is strictly less than f evaluated at x sub 2. Whenever x sub 1 is strictly less than x sub 2, and these two x values I'm referring to, x1 and x2, are actually in that interval I. Now, Nabil, you got to check out that is an actual strict inequality. And so I want you to plant one foot at x equals x of 2 and another foot somewhere to the right of it, no matter how close it might be to x of 2. I think the relationship in the y values is still a strict inequality, even though I'm including that left endpoint.
So if we have a horizontal line and an interval on the horizontal line, what is happening there? Nothing?
I agree with your statement, nothing. In the sense that because this has to be a strict inequality with the y values, I think the function is neither increasing nor decreasing over that interval. I might say in English the function is constant over that interval. But that means it's neither increasing nor decreasing because that's strict inequality. Nabil, are you okay with this? I'm serious.
So every number would be a critical number over that interval.
Very good point. I think where the function is constant, I think every value of x would be a critical number. I agree. I agree.
Wait, say that again?
Yes. Randall's saying this. What if I got a function that's constant over some interval line?
Okay.
Doesn't it mean that every value of x in that interval is going to be a critical number? For free?
Yes.
Because I think at every value of x, the
Horizontal line.
function is going to be equal to 0.
Okay.
Nabil?
I don't see why that definition doesn't include as increasing, like, say, something that's less than x sub 1 and greater than x sub 2.
I'm sorry, Nabil, I missed that one. I apologize. I'll pay attention.
You know how we got negative infinity to x sub 1 and then x
Yes.
sub 2 to infinity?
Yes.
Well, where that definition does it not allow you to just call, like, I don't know, something that's less than x sub 1 and something that's greater than x sub 2?
Well, I think he's saying like number that could be in between both points, but on either side of.
Well, no. I mean, like, I don't know, let's say x sub 1 minus 1, and then x sub 2 plus 2, and their f of x, the f of x value at x sub 1 minus 1 is less than the f of x value of x sub 2 plus 1.
Talk about the slope of the secant line.
Now, Nabil, you got to be careful. Actually, I was being careful with my choice of words. I never used a unit symbol there. I said, I think my function is increasing over this interval. Stop. Oh, my function also is increasing over this interval, but I would never take my definition of increasing this and choose a value of x in this interval and then a value of x in this interval because I think they're completely separate.
But that doesn't say so in the definition.
I think it does because when I say increasing over some interval I, I'm saying here's some interval I. Stop. Just that interval, over that interval only I'm increasing. But also a separate interval I is this one over here and over this interval, Scott. It is certainly the case. No matter where x1 and x2 are, then x1 being less than x2 means that corresponding y values have the same inequality relationship.
So x sub 1 and x sub 2 aren't like constants really, they're...
Quite the contrary. As a matter of fact, if you look at my definition carefully, I'm with this keyword whenever, it really means this. This has got to be true for all choices of x1 and x2 in the interval for which that inequality holds true. It's got to be true for all of them.
Okay.
That word whenever really identifies that that's got to be the case.
Okay.
Do some, yes, sir.
Well, I was wondering, what's the name of the graph that is, or who created the graph where it's continuous everywhere and differentiable nowhere?
Yeah.
I remember looking at or finding something like that online.
It's a French name.
Of course.
Of course it's French. Pronounced Dirichlet. So it's Dirichlet's example that gives it this. It's a function that looks like this. F is defined over at the interval from 0 to 1. This is way beyond the scope of this course. And f of x is, oh sheepers, now you put me on the spot.
You want me to Google it?
I might be able to do it faster than that.
That's a challenge.
That's a challenge.
On.
I don't have a smartphone, I was just speaking.
I'm not. Oh, no. It's not.
Double check the word. Might have gotten it wrong.
D-R-E.
On your phone, can you really do it that fast?
Yes.
Is that really a phone?
Yes. Okay,
Sorry guys, I just got my first tablet. I apologize. I mean,
D-I-R-E or D-R-R-E?
oh jeepers, am I that bad?
Well, it's spelled differently, two different ways. D-I-R-I. Boundary conditions, let's do it.
You know, I walked in the math center last semester, I broke my phone, so I had a new one, and one of the math tutors said, wow, you finally graduated, or you finally upgraded to 2004.
2004 was a very sad time.
Holy crap.
Or holy, because that's some serious math.
Oh, that's not it.
Oh, that's not it?
No, not even close. Yeah, it's all probability theory.
Oh, so not Dirichlet's distribution.
No, not to do, I didn't even know about Dirichlet distribution.
Yeah, that's
the first
what
thing
that
that comes
was.
up when you look up the name.
Oh, really?
Yeah.
I'm not a statistician, I'm a mathematician.
That
What
sounds
should I
like a
say?
jab there.
Yeah, it definitely sounds like a
It
jab.
sounds like a little jab? You mean little? Big jab.
I didn't say little, I just said jab.
Many universities across this country don't even teach statistics in math departments.
So what's M fun?
Except for
It's not math.
I won't go there. I'll get in trouble. So all I'm saying, Randall, if your number is expressed as a ratio to integers, it's a rational number. And if it's rational, just look at 1 over n. Think of that as the output of your function if it's rational. Think of the output as 0 if it's not rational. Quite the contrary, I'm just looking at the interval from 0 to 1. Actually, what the function will look like is this. Here's the y-axis. Here's the x-axis. Here's 1. It's going to have a bunch of points like this, not connected. Because at every irrational number, the y value goes down to 0. Yes, it's just popping all over the place. It's a very interesting sense.
Are there no two rational numbers that are next to each other?
Never.
Really?
Between any two rational numbers, you will be able to find an irrational number.
How's it continuous though?
It's not.
What wasn't the criteria of it?
Oh, what was your question? Sorry.
I thought it was like, is continuous everywhere differentiable nowhere? Or was that wrong? That doesn't make any sense.
Yeah.
It's like a contradiction.
Nothing's impossible.
I thought you said it's differentiable everywhere and continuous nowhere.
Well, differentiability implies continuity. So I think you meant it the other way around. Interesting. Do you know how many rational numbers there are between 0 and 1?
Infinitely many.
Infinitely many. How many irrationals between 0 and 1?
Infinitely many.
Infinitely many. There's a heck of a lot more irrationals between 0 and 1 than there are rationals. Meaning there's 2 different levels of infinity.
So,
Actually, there's infinitely many different levels of infinity, but those are the first 2. Are you guys interested in 60 seconds for instant PhD in mathematics if you can answer this one question?
Sure.
You take a peek at the level of infinity, which is the size of the rationals. You take a peek at the level of infinity, which is the size of the reals. Question. Does there exist some number c such that it is sandwiched strictly in between these two? We don't know the answer. We don't.
You mean it's not strictly math B?
No, that's not strictly math.
Be damned.
And so we haven't proved the answer is yes or no. We think it's no, but we haven't been able to prove it yet. Yeah, aleph not, and aleph symbol. We use the aleph symbol for different levels of infinity.
Cool, where's my PhD?
I got an idea. What do you think you can possibly say about the slope of the tangent line from here to here? Now be careful with my notation. I'm being very careful at the board. What can you say about the slope of the tangent line for the graph of this function over this interval?
It's
Positive,
increasing.
positive,
It's positive.
If a function has a first derivative which is strictly positive over some interval, does that mean it's increasing over that interval?
Yes.
Yes, it is. And so I think I can proclaim that I've got a test for increasing this and decreasing this. If f prime of x is strictly positive over some interval I, then f is increasing over the interval I. I think also if f prime of x is strictly negative over some interval I, then f is decreasing over that interval I. Oh shoot, have I just contradicted myself? Darn it. Since f prime of x is strictly positive over this open interval, it means that f is increasing over this open interval, and that's what this test says. But I would have gone beyond that and said f is actually increasing from negative infinity to x and 1 close the right endpoint because f is defined there and is still satisfying my definition of increasingness or decreasingness relative to my math B definition on the very far side way. So be a little careful. Sort of like saying this. If a natural number is prime, is it divisible by only itself in 1? Oh, that's a question.
Oh, that was a question.
Yes.
Elementary school
Yes.
question.
Yes.
If a natural number is divisible by itself in 1,
Yes.
is it necessarily if I got a number that's prime, is it necessarily divisible only by itself in 1?
No.
Yeah,
Yes.
but I can't use this as my definition, because I think I've got other natural numbers that are divisible by itself in only 1 that are not prime, like, I'll say that again. I think I've got some other natural numbers that are not prime that are also divisible only by themselves in 1, namely,
1?
1 is a good example, because 1's not prime.
No.
2's only divided by itself.
But 2 is prime, because my definition of prime is that I've got a natural number with exactly 2 distinct natural number divisors. And 2 has exactly 2 distinct natural number divisors, namely 1 and 2.
Oh, okay.
So I think,
1 only has 1.
thank you, and therefore it's not prime.
Okay,
I
got
agree.
it.
What do you guys think you could say about this? Actually, this is such a big deal. Can I put this in mirror form? So let f be continuous over some interval I. Actually, how about I say this? Let f be continuous over this particular interval. And differentiable.
Is that AB?
It is.
Those are beautiful A and B's.
Thank you. And it's differentiable over the corresponding open interval. Aren't you glad it's not? And suppose C is a critical number. changes from negative to positive about x equals c, then f of c is a local max. If, however, f prime changes signs, actually specifically from positive to negative, about x equals c, then f of c is a local minimum. And if it is the case that f prime of x, excuse me, just f prime, does not change signs, about x being equal to this critical number, then f of c is neither a local max or a local minimum. Now you guys, I'm the one putting this board, I'm the one who comes to class saying, oh, I need to be careful with my language. Technically speaking, I think I made one small blunder. Technically speaking, my function f doesn't really have to be differentiable at x equals c, because it's a critical number. Nabil?
Your tests for increasing and decreasing don't include the endpoints.
Why not?
Because,
Oh, the test, I thought you meant my definition.
yeah, so should we like add and the endpoints?
I agree with you 100%. So I think using my test for increasing this and decreasing this, I would say, oh, certainly my function's increasing with this interval. Do you agree?
Yeah, if you close the...
Well, no, just using this test for increasing this, decreasing this, I think I'm definitely increasing over the interval from negative infinity to x of 1. It's just that because I'm well versed with my definition of increasing and decreasing this, if I were to answer the question over what interval is a function increasing, I would have closed that right endpoint. Don't sit there and say, oh, well, I've got to use this test for increase and decrease, and this whatever it says is done. There might be other values of x for which you're increasing and decreasing that this test does not cover. And that's why I put this example up here, for you to see that this is the correct answer, although the test for increasing is only guaranteed me this initially. But once I got the graph, I really understand that I've got to include that right endpoint as well, namely x of 1.
Well, is that the only occasion on which that test won't yield our complete interval?
No.
What's another example?
No. Here's another good example. X, y. Here's x of 1. I think here at x equals x of 1, the tangent line is not even defined. So unlike my previous example over there, the tangent line is not horizontal x equals x of 1. But I still think I need to include x of 1 as a right endpoint in that interval. Nabil, I think this is a very distinct example, separate from the one on the left board, because on the left board at x equals x of 1, what is the numerical value of the slope of the tangent line at x equals x of 1?
0.
0. What's the numerical value of the slope of the tangent line at x equals x of 1 in this picture?
Undefined.
Undefined as a real number.
Well, yeah, but it's still the same thing. It's just the endpoint of your interval.
Okay, you insist. I still think it's quite different than my last example, because the derivative function was undefined at x of 1 here, but defined over there.
Well, that would just imply that you wouldn't use a closed bracket, you would just use an open bracket, because,
I think quite the contrary. I definitely want to include a closed bracket.
but it's undefined at that point, why would you?
The derivative function is undefined, but the original function is defined. See the difference?
Yes.
What kind of equations would give you the sharp corners, kinks, and cusps in the graph? If you were to just guess what the equation that you drew was, try to approximate. Oh, okay. I see.
And the graph will look like this.
The hypocycloids.
Like what?
Never mind.
I'm sorry so slow, you guys. Got a cusp
Yeah.
at that particular value. That'd be a good example.
It's basically just a shift.
Yes, Yes, it would, you're right. Actually, a shift and a reflection would be. A shift and a reflection. Oh, you know what? I think I grabbed it incorrectly, Randall. I forgot to reflect it. I think, my apologies. I'm misguiding you. Here's the negative one. Sorry I'm so slow, you guys. Actually, look like this. I forgot to reflect it in my head.
That also has all these quadratic properties.
Yeah, no, I'm just saying, officially speaking, I shouldn't be sitting in front of class saying that's a graph, that equation, because in my head I forgot to reflect it. That's better. Man, I'm still wrong. I'm still wrong. Jeepers.
Shifted to the left, right?
No, it's just shifted up, not down. My goodness. Oh, you're not going to believe anything I say about it, are you? At least I admit when I'm wrong, okay?
Unlike our book.
I'm not. Wow, you guys. This, I know I've erased half of it. I'm so sorry. That is so important. Can I give it a name? I think this result will be such a big deal. I might as well refer to this as my, oh shoot, it's so big. It's so big. You're reading ahead of me.
First derivative.
Thank you.
First derivative test, yeah.
And I think it's this first derivative test that's going to allow you and I to graph significantly, better than we've ever done before, and also going to allow you and I to maybe answer some serious application questions with the calculus, which is, how do I optimize certain physical phenomena? How do I maximize them or minimize them? It is going to be that much of a big deal. Shoot. Maybe the big deal is going to have to wait for 2 minutes. So far, so good.
Second derivative test, right?
Second derivative test tonight as well,
Is
absolutely.
this still 4.1?
No, I'm into 4.2. I'm at a 4.1.
Follow-up question.
Yes, sir. David.
The test on Wednesday, how far do you feel that we're gonna get on that?
When I come to class, I'm not going to answer any questions. And I will be covering both sections 4.3 and 4.4.
And it's gonna be through 4.4 then?
Yes. No ifs, ands, or buts.
So you mean on Wednesday coming up you'll do that, and then what are we doing on Monday then?
I have no clue, but whatever I do on Monday won't be on the exam.
Like finishing chapter 4.
Yes.
When is the exam? I wasn't here the last.
I haven't changed anything from the syllabus. It's still a week from this Wednesday. A week from this Wednesday. So next Wednesday. Gosh, you guys, we're almost done, aren't we?
Yes.
What,
It's almost May.
so what are we going through again in this class? Which chapter?
5.
You mean to end the course?
Yeah, by the end of this course, yeah.
The end of chapter 5.
Is the door closed? The end of chapter 5.
The end of chapter 5.
Don't yell at me.
You didn't believe me?
How long is chapter 5 again?
It's pretty short. It's pretty short.
Okay.
It's 5
Oh, okay,
sections long.
okay, yeah.
Isn't 4 like 12 sections though?
I don't think so. I think it's 8 sections.
8 sections?
Yeah, there's the hospital one, and then there's,
Well, not really 8 sections. There's something missing.
Bubbles.
They're all over you. Burn them.
I feel like someone's got
If you guard it with bubbles, so usually they have a different composition than regular.
Have you ever tried burning a bubble? You don't know that.
Well, aqua bubbles.
So just making sure, the test is on the 1st, right?
It's Wednesday's the
Like
first.
a week.
yeah.
Better be.
Wait, what?
There's not 2 more exams after that.
We have one more exam after that, the final.
Yes, I'm sorry I'm so slow to be
Oh, it's
the
okay.
first.
Okay.
That's crazy.
So this
And then,
test
So-
is
do you
final.
know yet what's gonna be, which sections are gonna be on the test?
All of
Yeah,
chapter
all the way
5
through
is
4.4.
4.4?
So 3.8 through 4.4.
So the final is cumulative, or are we just gonna cover the stuff that we
Both.
both have?
Pretty nice.
Yes, you're right, 3.8